Well, hello and welcome back to the channel. This is part 7, talking about the remote of adventures of building Nova SM3 robot dog. As before, I'll just show you where you can get the information from if you're interested in building Nova. The website and the Github and some YouTube videos of it. So we'll talk about the remote, and this is the back panel of the remote. So the back panel holds the battery and the 2 voltage regulators. It also held the NRF transmitter, but I've moved that to the front. So this is the original wiring arrangement with the NRF in the front. So the battery, the switch was on the negative, and that so you couldn't charge the battery through the balance lead unless it was turned off, but I'm not worried about that. I've just hooked it up into the positive, basically the same thing, but I've also put the output of the 3.3 voltage regulator through a connector. There's the connector to the NRF 24, which is now on the front of the transmitter. The reason for that is that the longer leads was causing a lot of problems with actually trying to communicate with the dog. So putting that closer into the front panel reduced the length of the leads, and that fixed the problem. I've also changed the value of the resistors from the circuit diagram that you download, but we'll talk about that a bit later on under the voltage feedback. So here's the back panel. So we have the 6.4 volt regulator. That's basically turned out flat out, so that's the maximum output can be, and there's a 3.3 volt one that's used for the NRF 24. So that's what the back panel wiring looks like, with the 2 push buttons that's on the back panel, and you can see that the switch is there in the positive line and the 2 resistors, the voltage feedback, and you can see that there's a red JST that goes to the Mega, and a multi-pin JST plug that does the rest. So this is the front panel. We'll have a close-in view there. So we have the right joystick, left joystick. The smaller of the displays and the bigger of the displays. They're just for LEDs, and the 4 sliders, and the 2 momentary switches, and the 12mm momentary switches on the front. What's not shown in the picture is the NRF 24, but that does get put in the front there. So there's a little bit better view of the wiring, the colours that I used, and the pins from the Mega and where they get connected to. So a late addition to this video, I just want to talk about the addressing of the 2 LED displays that are in the remote. They're I2C, so they're on the same bus, and they have to have a different address. But when you buy them, they've both got the same address, which is 0x3C. So we just go into the code and scroll down and have a look at the configuration. So we can see the smaller 32-bit high display is addressed as 0x3C. We can't change that physically. That's how it comes when we buy it, and we can't change it. So that is okay. The bigger display we can change. So we're not changing in the code, we're changing it physically on the display. So there's the 64-bit high one, and we can see the display, the address is 0x3D. So just to complicate things, some boards come with those numbers and some boards come with these 0x78 and 0x7A. The difference is one is an 8-bit address and the other is a 7-bit address, but they're basically the same numbers. So we just need to move the resistor across. So we get 0x3D or 0x7A. Resistor surface mount, so it is a little bit of fiddly to get it moving across. So just be patient and you'll get it across there, and then when that's right, the displays will work. We don't need to change the code, we just need to change it physically on the back of the big display. So we'll move on now to back to the video and talk about the front panel again. So that picture was without the Mega, and now we have the Mega. That's mounted on the 3D printed bracket. And the wires haven't been connected to it yet. And then we also got the double-sided printed circuit board, the prototype. So that basically just most of the common or grounds go there, and you have one ground, and most of the supplies or the plus 5 volts go to the other side. Just makes wiring a little bit easier. And now I just have the back panel again, but with the NRF in place. You can see the leads are directly connected to the Arduino Mega now, and I don't have any problems with the communications that way. Now just a quick look at what the front plate looks like. You can see some loose wires there, so the Mega's not completely wired up yet. So once all that's connected up, we're going to start hooking up the, putting the library in for the Arduino Mega. So first of all, with the Mega plugged in, I'm just going to make sure that we have the Mega connected, the board selected in the Arduino, and make sure we've got the right COM port. It says it's COM5 when I plug the USB lead in. If we scroll down on the sketch, that's called Remote-V5.2. We can see that we need these libraries. And some of these libraries we already have installed from the other one. The only one I think we need is this SSD1306, which is the display, the small display. So if you just type that in the library manager, see it comes up there. You just need to install that. And install all. So that's it, everything's installed, all the libraries are now done. So we'll just upload that sketch now just to confirm that it's all going to work. So now this sketch has been been uploaded into the Arduino Mega, and there's no problems with that. Now with the Mega connected and sketch uploaded, we're just going to open up the system monitor, and we need to connect the baud rate to 19,200, so we change this baud rate. So this system monitor, serial monitor is now hooked up and ready to go. So we can start checking that the software works and with the hardware. Previously, as with the dog, there's a section here where we can turn different debugs on and off, and also activate the different components. So we have the NRF, which is the radio transmitter. If you have hassles with that, you can just turn that off, because if that is on and the radio transmitter doesn't work, the whole thing just stops working. So here we're just going to put the debug on and the debug 5 on, and we'll upload the sketch to activate them. We're uploading now. So keep in mind that we've got the NRF activated, the battery and the activity activated. I'm not sure what that does. So now that we boot up, down on the system serial monitor, we can say that the radio is ready. That means that the NRF is working. If you don't get that signal, it won't go any further than that. Now we're getting these I counts. I'm not sure what that represents. But pretty soon we'll get up, because we've got the battery activated, and debug 5 is looking at the battery monitor. We should get the battery voltage soon in the system monitor. I think it gets updated every 30 seconds. There we go, so it's saying we're 7.75 volts. So we're not 7.75 volts, we're actually that's too low. I think we're almost 8 volts on the battery. So if we go down to this line 2 at 1235, you can see that's how it gets its battery voltage. So we just need to change this constant here. So a little bit of trial and error. I'm going to try 1.59. We upload that sketch to make that change. So that should change our... Okay, we'll just talk a little bit about the battery voltage monitor. There is a problem with the original circuit diagram. Here's the original, and I've got it circled in green where the problem is. That's the battery monitor resistors. The wiring is wrong in that. So I've changed the wiring. This is how I've done it for this video. The resistor values are not quite right, so R8 1K and R7 2K. That means 8 volts on the battery will be 5.3 volts into the mega, which isn't quite right, and that gives me a multiplier of 1.59. I've since changed that. The resistor values, the circuit is still the same, but R8 is 1K and R7 is 2.2K. So at 8 volts on the battery, that puts 2.5 volts into the mega input. So the multiplier there is 3.2. So I've made the video using the other resistor values, but I've since changed it to these resistor values, and the multiplier is 3.2. So back to the code. Like I said, I'm using the old resistor values, so there it's 1.59 is the multiplier. So I'll upload the code, and we'll wait for the battery voltage now to come up. I've sped it up 5 times because it takes 30 seconds for this to come up. So we'll see what that new value is. So it was 7.75 and now it's 7.95. That's pretty close. My battery voltage was 7.98 volts, so it's pretty close. I'm just going to change this value a little bit just to see if it gets a little bit closer. So I'm changing it to 1.61, and again we'll upload that and we'll wait for the battery voltage to come up. Again, I've sped up the video 5 times here to get that battery voltage. So again, in the system monitor, in the serial monitor, just waiting for the battery voltage, and it says it's 8.05. That's what it's displaying on the display as well. That's a little bit too high, so I'm just going to adjust it to 1.60 volts. But I eventually moved that back to 1.59. But like I said, I've since changed the resistor values now, so it's 3.2, that multiplier. So I'm not going to worry about waiting for that battery voltage to come back again and all that. What we're going to do now is we're going to change the debug again, and this time we're going to check the pot inputs, or the sliders and the joysticks. So control to serial joysticks, so we're going to make that 1, so debug 3 will now be 1, and we'll upload that. And in the serial monitor we will now get those values. And you can see that the battery voltage is 7.98. Okay, so the remote has started up, or it's booting up. When it comes up ready, it will be booted up. And now we can see the values of the potentiometers and the joystick. We'll just do pot 1 first. In the center it should be 128, down it will be 0, and up will be 255. Pot 2, same sort of thing. The centered position can be a little bit out. The important thing is that the up and down values are pretty close to that. You see pot 3 there is now 255. Pot 4, down is 0, and up is 255. So we'll push button 1. Go to 1 when it's pushed. Push button 3. Go to 1 when it's pressed. Button 2. Again, 1 when it's pressed. Push button 4. 1 when it's pressed and 0 when it's not pressed. Select 1 button. Again, when it's pressed it will go to 1. Select 2. Now we'll do the joysticks. So we'll do the left joystick first. You can see that that's going between, when it's all the way to the left it will be 1023, and all the way to the right it will be 0. That full number is not shown there, it's showing 102 because the 4's been dropped off. And we use the y-axis all the way up and all the way down. And the right hand pot, let's see, all the way down is 0, all the way up is 1023, and on the x-axis left is 0 and right is 1023. Now they're different from the left hand stick, but the code changes all that around. So now we've finished looking at the pots, making sure they work alright. We'll take that to 0, just so we don't get those numbers scrolling through on the serial monitor all the time. So we'll do debug 4 now. You can see on the display now it's above the ready there, it's showing that the lines there. I'm not sure what use this is, apart from showing on that small display where the slide pots are. Yeah, and they're very slow as well, so I'm struggling to see why you want them there at all. So normally you'd have debug 4 turned off. I guess the only other added feature I suppose is that you can see the values of the joystick there on that display. I struggle to see why you need that when the joystick's normally working, which is why you have debug 4 turned off. Okay, so we'll disable debug 4. Turn the battery monitor off, because we already set the battery up, so that's okay. So we'll turn on debug 2, which is the NRF24 serial comms. You need the dog powered up as well for this to happen, so you can get bi-directional communication. So now we got saying that the radio is ready. You see line 54 up there, so also saying that the NRF is activated. So we're getting some failures here because the dog hasn't powered up yet. So we're just waiting for the dog to power up. That's basically saying that the transmitter is transmitting, but it's not getting anything back from Nova. And here we're starting to get some information back from Nova. And now it's locked in solid now. You can see the values there. And we're getting data sent and acknowledged received. We move the joysticks and that around, we'll see that those numbers are changing. The important bit there is that we're sending data and we're getting acknowledgement back. Before I moved the NRF24 to the front of the transmitter, the radio wouldn't start up at all. It would, at the start of the download, the start of the serial monitor, it would say that the radio had failed. The dog had restarted then, that's why we lost communications. once it booted back up, it was okay. I'm not sure what column does what. Moving the pots and the slides around and pushing the button, you can see that some of the numbers are changing. If you don't get any of this, you need to maybe check that the NRF is in the right position and running in both the dog and the transmitter. So I think that's it for now for this video. We've got the transmitter up and working, communicating with the dog. Next video will be a little bit about the dog, Nova walking around a little bit, and that will be the last video, so that will be part 8. So thank you for watching, and we'll catch you next time.